All right, so the goal was to make a circuit in which the LED closest to the power supply was brightest, and the one farthest away from the power supply was dimmest, and ideally there'd be sort of a gradient in between. And this is a solution, not the only one that you can make, but a solution to that, where I've placed smaller resistances in the branches closer to the power supply and a larger resistance in the branch farther away from the power supply. Now if we hop over here to the actual circuit on the breadboard, the LED lights unfortunately don't seem to show up particularly well on the camera, though you can see a difference there if you look carefully. You see the 4 branches in the circuit. They come across the breadboard with the resistors in series. We've got some connections back to our power supply over here, currently at just over 2 volts. And we've got some voltmeter leads running back through those wires all the way back up to there, where it's displaying the measured voltage that the power supply is outputting for the circuit. Okay. Now, if we look closely here, you should be able to see the striping on the resistors. That first one is brown, black, brown, so 100. Then red, red, brown. The colors are a little indistinct there, even in real life. So that's 220. This is orange, orange, brown, so that's 330. And that one, if you squint, okay, is brown, black, red, which means 1000, so 10 times 100. Now there are, like I said, other solutions to this, but basically all of them involve limiting the amount of current that will go to a particular branch of this LED circuit. Okay? And maybe to get the full effect here, we can bump up the voltage just a little bit. Go 3 volts. Sure. Now they're glowing a little more brightly. You should be able to see it just in this video, but let me pop over here. And there you go. Okay, bright, less bright, and least bright. Okay. So that's all to do with limiting the amount of current that goes into each branch. And that's all down to the resistances that we put in each branch. Now what complicates this a bit is, well, the LED is non-ohmic, right? So as it turns on, its resistance drops considerably. And so because these LEDs are outputting different amounts of light and receiving different currents, we would expect their resistances to be different as well. Lowest for the brightest one, then higher, higher, and lastly even higher for the last branch. So not only is there a larger resistor in that last branch, the resistance of the LED further limits the current flowing in that branch and reinforces the effect a little bit. Okay, and in the experimental data that I put out for this, I will measure out some of these voltage drops so that we could sort out what the resistances would be in each case. Okay, so but for now, 3 ohms total applied, 3 volts measured, and that's being applied a parallel circuit, which we see the diagram in a slightly darkened room right over here. Okay, so we'll engage in a little bit of analysis, but there's the effect demonstrated. See you later.